Welcome back to the course C# Advanced Language Features. I'm Philip Ekberg, and now it's time to learn all about pattern matching. Pattern matching isn't a new concept. In fact, it's been around for ages and have been a part of programming languages such as F#, Kotlin, and others for a very long time. In C#, however, it's a fairly new language feature and was only first introduced in C#7. At that point, the language feature was rather limited. As with many other language features, such as tuples and lambdas, newer versions of C# may introduce additional improvements. This has been true for pattern matching as well. Since its first appearance in C#, there has been a lot of improvements. Future versions of C# will most definitely continue to introduce new patterns that will make your development easier. So, what is pattern matching? And why is this such an important language feature? I'd like you to consider the order in the warehouse management system. As we pull this object apart and look at its different values, properties, how it's deconstructed, we might want to construct an expression that lets us determine what the order is. Is the instance of a specific subclass? Is it marked as ready for shipment? Is it a canceled order with an amount less than a certain value? All of these questions can be expressed using pattern matching. Prior to the introduction of pattern matching, you would have ended up writing a code snippet that checks a given type, look at different property values, and then based on that, it would perform some operation. In the simplest explanation, a pattern is just another way of allowing you to express what you assume the object is and what that may contain. Normal if and else if statements can quickly become hard to read and maintain if you have to write complex checks. This is where pattern matching will be a tremendous help. Of course, as with any language feature, if you abuse it, the code may just as well become hard to understand. Take this simple piece of code as an example. We'd like to check if the type of the shipping provider used with this order is a Swedish postal service shipping provider. This class inherits from the shipping provider. So after we've checked that this is the provider used for the order, we'd like to consume this as a Swedish postal service shipping provider. Using the is operator will determine the type, as well as if it's not null. This will use what is known as the type pattern. An alternative way would have been to get the type from the instance by calling getType and compare this with what you'd get from type of. You'd have to manually cast the shipping provider to the correct type and then store this as a local variable so that it can be reused within the statement. With pattern matching, this becomes easier. The if statement isn't extremely complex at this point. But what if we'd like to check a property that only exists on the provider? Then, all of a sudden, you'd end up with a nested if statement. Using the is operator is one way of using pattern matching. The right-hand side of the is operator is where you'd define the expression for the pattern. We can expand on the pattern to express much more complex expressions. For example, we can specify that we want this captured in a local variable of the correct type. To do this, we add what is known as the declaration pattern. This will mean that inside this statement, you can use the provider variable as a Swedish postal service shipping provider without having to perform any explicit cast yourself. We've reduced the amount of code by a fair bit, and this becomes even more powerful when a more complex pattern is applied. Throughout this module, you will explore all the available patterns and how they're used in different ways. You will learn about the following patterns: type, declaration, constant, relational, logical, property, positional, var, discard, and parenthesized. All of these patterns can be used in 3 different ways. The first option is that you can use them together with the is operator, as we've just explored. Second, you can use it with a switch, where each case in the switch statement uses a pattern. This can be used together with a case guard known as the when keyword. The if statement that uses the is operator can be converted into a switch statement. If you'd then like to check a property, you can do so using the when keyword followed by what you'd like to check. This introduces a case guard. The order will be the actual type that you matched on, and also available in the case block. The third and final way is to use this with what is known as a switch expression. This is what many developers will prefer, as it's more compact and usable in many different situations. It also makes it easy to understand exactly what you are looking for and what the intent with each match is. Being able to use patterns in all these different situations means that you can write code in the way that you prefer, and even easily convert old code into using patterns to make it more understandable. As you explore each different pattern throughout this module, you will notice that you may combine and use more than one pattern. This is known as recursive or nested patterns. An example of a recursive pattern could be that you first check the type. This will also ensure that it's not null. Then, after the type has been checked, we'd like to check a property value. Let's say that if the order has been set to use the Swedish postal shipping provider, and the freight cost is more than 100, we'd like to add a discount to the order. What we've expressed here is in fact introducing a recursive pattern. First, it checks the type. Second, it accesses a property to verify a value. Third, it uses something known as a relational pattern that lets you check, for example, if the value is greater than your constant. I know there's quite a bit going on here, and we'll look at each piece individually throughout the rest of this module. As you've now seen, pattern matching is powerful and allows for simple and complex patterns, which let you express the intent of your code in a more intuitive manner. Let's now continue to explore pattern matching in C#. And in the next part, we are going to introduce a switch expression.